In this video, we're going to talk about solving exponential functions using logarithms again. We're just going to go a little more in depth, and we're going to talk about a little bit different of a way that you can solve these, and how you can solve them if they have a little bit of extra stuff, not just an exponential by itself on one side. So if I see something like -3 times 5 to the 2x power is equal to -48, I want to rewrite this so that there is only a base raised to an exponent on one side and a constant on the other. So what I want to do first is I want to simplify to some base raised to an exponent is equal to an answer. Right now I have an extra -3 in front, so that -3 is being multiplied. I want to divide by -3 on the left to get rid of it, to undo it, to get that 5 to the 2x by itself on the left-hand side. And if I do that on the left, I have to do that on the right. So that's my first step, and I'm going to end up with, when I do that, 5 to the 2x power on the left and 16 on the right. So I've simplified to some base raised to an exponent is equal to an answer. The next thing I'm going to do is, in the last video, we talked about taking the common logarithm of both sides. What we could also do is we could take log base b of each side. So we could take log base b of each side. So I could take log base 5 of both sides, since this base is 5. And then I'll have log base 5 of 5 to the 2x power is equal to log base 5 of 16. What's going to happen when I do that is I'm going to see that on the left, I'm going to end up with just 2x, because 5 raised to what power gives me 5 to the 2x power? Well, that's 2x. And so the next step, or what I want to do, is I want to simplify. So I want to simplify what I have, and I'm going to end up with, on the left, 2x, like I just said, and on the right, I'll have log base 5 of 16. And then after I do that, I'm going to just solve for x. So I'm going to solve for x. And first thing I'm going to do is I'm going to take what I have, 2x is equal to log base 5 of 16. I'm going to rewrite the right-hand side as, using the change of base formula, as log of 16 divided by log of 5. And then from there, I know that I have 2x is equal to, if I do this in my calculator, I'm going to get 1.723, and then I'm going to divide both sides by 2, and I'm going to get that x is equal to, I have 0.861, and that's my answer. So the first thing that I want to do is I want to get I want to simplify this so it just has a base raised to an exponent is equal to a constant. So I'm going to get rid of this -3 that's in front. I'm going to divide by -3 on the left and the right, and I'm going to end up with 8 to the 8m power is equal to 11. From there, I'm going to take log base 8 of both sides. So I'm going to do log base 8 of 8 to the 8m power is equal to log base 8 of 11. So I have log base 8 of 8 to the 8m power is equal to log base 8 of 11. What I can see is, what do I have to raise 8 to get 8 to the 8m power? And that is 8m. So I know if I simplify this, it's going to be 8m is equal to log base 8 of 11. From here, I can rewrite this as 8m is equal to log of 11 divided by log of 8. I want to solve for m. And then from there, I can write 8m is equal to 1.153 if I do this in my calculator. And I'm just going to divide both sides by 8, and that will give me that m, not x, m is equal to 0.144. I want you to pause this video and try this one on your own. Think about what this one has extra on the left-hand side that you have to get rid of. What you should have done is you should have divided -1 on both sides to start. You should have divided by -1 on both sides to start, and you would have ended up with 6 to the x power is equal to 61. you would have took log base 6 of both sides. So log base 6 of both sides. That's 6x on the left and 61 on the right hand side. On the left, that's going to simplify to be just x is equal to, and then I'm going to do log of 61 divided by log of 6. And when I do that, I'm going to get x is equal to, my answer is 2.294. That's what you should have got. All right, for this one here, I have 18 to the 4x minus 6 power plus 3 is equal to 54. So the first thing I want to do is I want to get this base raised to an exponent by itself on the left-hand side. So I'm going to subtract that 3 to get rid of it. I'm going to end up with 18 to the 4x minus 6 power is equal to 51. And then I'm going to take the log base 18 of both sides. So I'm going to do log base 18 of what's on the left and log base 18 of what's on the right. So I have 18 to the 4x minus 6 power and log base 18 of 51. And when I simplify this, I'm going to get this is what do I have to raise 18 to get 18 to the 4x minus 6 power? Well, that's 4x minus 6 is equal to, and then on the right hand side, if I evaluate that, it's going to be log of 51 divided by log of 18. If I do this in my calculator, I'm going to get 4x minus 6 is equal to, that my calculator is 1.360. I'm going to add 6 on both sides. I get 7.360 is equal to 4x. I'm going to divide both sides by 4, and I'm going to get that x is equal to 1.840. And I want you to pause this video and try this one on your own. All right, what you should have done, you should have gotten rid of this 8, the minus 8 on the left-hand side, so that you just get the base raised to an exponent by itself. You're going to add 8 on both sides. You're going to get 10 to the 6x plus 8 power is equal to 0. You're going to take log of both sides because this log is base 10. So I'm going to do, and you can write log base 10 if that's helpful for you. Log base 10 of both sides, or just the common log of both sides. You're going to get log of 16 to the, oh my gosh, what? Log of 10 to the 6x plus 8 power is equal to log of 0. If you don't really have to continue from here. You can't have 0. You can't raise 10 to some power to get 0. So the right-hand side is undefined. It doesn't make sense. The answer is just, I don't have to do anything from here. I know it's undefined. It doesn't matter. 6x plus 8 equal to log base 10 of 0 doesn't make sense. So that's it.